Okay. Yesterday we discussed till here, right? So what exactly the ETL is? So today I will try to cover the this uh, so some of the terminologies and types of loads and the data warehousing concept, OLAP, OLTP, and the data model, and uh, yeah. So we'll complete those today. So before that, I'll tell you some of the small terminologies we'll use in the projects. Okay. Uh, yeah. So actually, uh, in the projects when we are working in the data with the databases, we'll be working doing this data cleansing or data scrubbing. What exactly it is? So it generally it's a process of removing the irrelevant information which is not related to particular database, like exactly, let's take you're working on the retail one, so we see some of the information which we don't need but it exists, or redundance means a kind of duplicate data. So uh, duplicate data, either if we see uh, uh, there is some incorrect data or incomplete data, we will do the data cleansing. So this comes under the kind of it will help us to uh, improve the database performance and the runtime, and it will helpful for the improving the storage of the database. So for example, let's take uh, I want to fetch in a table. I have around 1 million records. So it might take around maybe a half an hour or some time. So in that also we have some redundant, means that the data which is repeated and the data which is not related to us. Out of that, I removed and I have only 100K records. So I can fetch these data in the seconds. So that's how we can improve the our query performance also. So that's why this is important, uh, removing the information which is not related and updating the information. So if you are working on the incorrect information, that might give you the results how you are expecting. Okay. And there is one more concept called the data masking. Uh, Data masking is normally nothing but the original data, whatever you store in the information in the database, you will replace that information with some other information, because you want to hide the original information. Uh, you want to hide, or uh, you may mask it, or you can say it the encryption, because it's a sensitive information. So while you are working in the let's say you are working in the bank project. So in that bank project, uh, so you might have the sensitive information like the personal PII, personal identification information. So that might should not reveal um, to unauthorized persons. So that's why, for example, maybe let's take we have one person, we know their name, SSN or address, phone number, and all. So we don't want to reveal that. So what we'll do, we'll replace it with the maybe other alphabets or the numbers, or maybe some with other special character, or we'll shuffle the something. For example, we have this 1 2 3 4 5 6 7 8 9. Maybe it's a SSN provided in the US. So normally it should not be revealed. So what exactly we'll do? Mostly like we'll only reveal last 4 digits, because the entire SSN should not be revealed anywhere to other teams. For example, you give this data uh, to sales team for the marketing or some other purpose, maybe some verification purpose or something. So they don't need to know the entire details. Yeah, helpful to replace the original value with a dummy value. So generally, uh, there is one organization called the GDPR, Global Data Protection. I forgot the name. I I think Global Data Protection Regulation. So if they comes to this GDPR, customer is just like saying like, uh, I don't want uh, uh, as a individual citizen, I have fundamental right and freedom to protect my own personal data. So I want my data should not be used anywhere. So it's kind of a DND, do not disturb, so that if they come through this, we should, for sure, uh, uh, we should not use the customer information. If we use it, customer might uh, sue the company. Okay. Uh, and there is one more concept called the data retention. So mostly like on day-to-day basis, uh, as a if you're working in any data role, so mostly you will be interacting with the any database. So whatever the concepts I'm saying, these are not the a practical one which I can show you, but these are the theoretical concepts you should be remembering. Okay, so that it's kind of a good to know information for you. So you need to understand the concepts to work around the this data profile. Okay, so data retention is nothing but how long we can store the data in the database. Okay, so for example, I have some volume of data, maybe around 10 minutes of data. Uh, I I'm storing this data from uh, past 5 years. Okay, so uh, in that also, there is some data I'm using, I might not using, and that is the one point. And the second point is like, we need to abide with the uh, government rules and regulations. So government will ask us to not use the customer data which uh, we are not using them, like the data which we are not using anywhere, it should not be there in our databases. Actually it should be archived. So for this also, actually uh, there is one team called the governance team. In every company, if you are working in the data level, this governance team will do the auditing. Every year, we'll be having the internal auditing and the external auditing. So in this auditing, they will try to find whether we are uh, uh, breaking any government rules. Like maybe you've seen in the news, like the MNCs, the large companies, uh, they are not following the government rules. Because of that, uh, they had a penalty. So that's why they will have this team. So they will have some auditing and they will check it. I think Colibra is one of the one they will use for this auditing and all. So this is also one of the important thing. And because of this, like mostly like the companies will, maybe they will use uh, a quarter or more than a quarter. That's it for the data retention. After that, they will remove it. So these are some of the like if the unwanted data is available, again the performance will be impacted. So that's why they will remove it. And we are occupying the uh, data in the database. So whenever the companies store the information, they will pay for the servers. For example, they buy around 100 TB of server. It's a storage server. So they need to pay some millions of millions of dollars to the that server company. So that's why they will try to do this everything, like the data cleansing and all, the data retention. Okay. Yeah, I think we discussed about. So uh, I'll tell you normally there are two types of loads we use while working. What are those? So I told you, right? We'll be working with the ETL. So in that ETL, we'll be getting the data. Majorly, you can consider there are two types we'll get it. Uh, I told you, right? Uh, Batch job and the real-time job, real-time data. Real-time data, you know. So for example, we all working in one Excel sheet, which is shared across everyone. So in that Excel sheet, whatever the changes if I'm doing, that will be reflected across every user. Means you can see the real-time changes over there. Just like that, whenever the data in the source something happens, that will be captured in our databases uh, in a real time. So there is one more called the batch job. In that batch job also there are two types. I'll I'll tell you those. So first one is first type is a full load or bulk load, or we can say full refresh load. So this is a time where, for example, we got a request from the business saying, I need to build one source. Let's take it's a for the Salesforce. I need to take some data. I need to do some ETL work. I need to store the information in the target, which is MySQL. You can consider it as a data warehouse. So, what exactly here I'm doing? So I'm creating this entire flow for the very first time. What are this flow I have created? I'm creating this flow for the first time. So I don't have any data in MySQL for this entire flow. So I'm getting the data for first time. So this data we are loading for the very first time, the dump, which is taking for the first time loaded into warehouse. So entire data whatever we have, you are getting into a target. So that's where we will use this initial load. We'll call it as a full load or bulk load or full refresh load. Okay. So once, for example, let's say you have already some data over there. Let's go with the color coding. Uh, so you did some load initially. We ran this. Uh, let's take we have one job, uh, Salesforce job in the ControlM. It ran on the yesterday. So I already got some records, maybe 100 records I got. For the Salesforce job, I'm trying to do the run for the daily. So the run completed. On the next day, I ran again. For today. So in the backend, in the Salesforce from the source, we got maybe around 50 records added. So this on top of 100, it has to add few more 50. Total it should be 150. So tell me one thing, like, is it already we have this 100 records over in our target? If you is it a correct way, and like is it a good practice to load again this data? So uh, or else we'll only load this 50 records into the target. Which one is the best? Any guesses?
I think only 50.
Yeah. So because uh, it doesn't make any sense, because already we have this 100 records data in our with us. Even though we are trying to load, it might take some time, and uh, it is an unwanted step we are doing, and we are wasting the company's time and business time. So that's why whatever the modified data alone, it will be updated in the target. Okay. So that's where this incremental load will come. It is an incremental load. We can say, uh, let's forget about refresh load. It's only an incremental load where we load only the modified data. Uh, this will do from the second time, from the second run onwards, it will do. Yeah, actually, I'm telling this in hundreds, and that's it. In real time, while you're working in the data level, you might see the many records. So uh, let's take for the 100 records, you can calculate simply. Maybe it's taking 1 minute. So you have around maybe a 10 lakh records. So that might take maybe a 100 minutes in a simple way. So that's why uh, we'll only load which is uh, the newly came into the our system. That's it. Or else there is one more chance. out of this 100 records, let's take, we have actually three categories you can remember out of the data. For example, new records comes under the inserts, means we are inserting the new records, or we have the updates, uh, and we have this deletes, means according to our requirement, if the data which is not suitable, we'll delete them. Okay, so mostly we will do these operations with the data, because some maybe one customer which uh, we are serving, the customer unfortunately expired, or customer is no more using our services. We might example, like we need to delete the customer data, or else customer may move to new address, or he's changed his mobile number. So in terms of that, we need to update the information over there. Else, let's take for the inserts, we added a new customer, like there is a new customer we are serving. So in that scenario, we need to insert that information into our database. Okay, so this is types of loads. Just a second. We completed this types of data. ETL cycle one has been completed. This is not required. Actually, I'll show you one document that will be helpful for you. Where it is. Yeah. So while you're working in the project, I told you, right, you might receive the technical specification document, or business requirement document, or we can say anything, FRD, functional requirement document, all are same only. So this will be provided by the either PO or BA. PO means product owner, which will be act as a bridge between business and IT team. Let's say uh, we are working in one technology, so they ask us to build some data in the ORCID. So they are asking to simply create these tables in the HR, but uh, we are not own this, right? Where we can't take this ownership. So PO or BA, they will take the information from the business, what exactly we need to do, and they will give that information in the documents or in somewhere written. According to that, we will work. So if you see here, this is called normally as a mapping document. Okay, so mapping document is nothing but you will have the source to target, how exactly we need to load the data. If you see, they will clearly mention what exactly, let's say, the project name we are working, and the source name, and what is the target it has to load, and who is the owner, who is the stakeholder. Every detail they will mention. Or else, from the source, maybe you are getting the data from Salesforce, maybe, or from, there is one more uh, file. From the file also, we might get the data. How you will get the data normally? Uh, age, salary. So, like this, they will store the information normally and they will save this as a flat file. EMP. Like this, they will store employee data. So this will act as a flat file. They'll simply say text file because if I tell you, uh, if I show you here, this is normally a flat file where mostly they will use this CSV, comma separated value. Means if you observe here, this is a plan ID. After that, you have the plan name. After that, you have the plan EFF. So likewise, in between, there is some special character you are using. That is, we call them as a delimiter. Okay, delimiter. Delimiter is nothing but one special character we are using between the uh, two different data sets, not the data sets, between two different data, so that you can identify easily. Okay. For example, I'm using here the comma. So some might use this pipe or some might use this, mostly they will use this comma only or else the pipe. So I'm using here comma. Some might use pipe. Mostly pipe or comma only used in the projects so that it can easily detected or understand it by the computer. So the machine can understand easily or even we can. So we'll use like this or sometimes we may get the data in the .json or .xml files also. So mostly text files only. Text files or .csv files. Mostly they will use these only. Okay. So from the they will say, I need to store this information in the HR schema. They will all give the details. So, but you need to understand this. Whatever the if I say he's saying uh, first name. First name is the what it say. Uh, they will clearly mention what is the column name, what exactly it does, what is the data type, and what is the data length. So you need to understand what exactly that columns do, what is the data type. I told you, right? Uh, we'll be handling only majorly three types of data we'll be handling, mainly text, number, and date. So varchar comes under the uh, this text format. Okay, and length. Length means, for example, let's take we have the name. Name. I'm saying it should store the text format, text data with uh, 8 or 7 characters. So whenever I'm giving this information, I'll try to store the any information more than 8 digits. It will not allow. It will only store the 7 characters. That's it. So that is the length we say. So I'll show you the data structure. You'll be having the understanding on this. Let's try employees. Okay. Meanwhile, we'll see. So, like even they will provide these transformations as well. Like you can see, he's saying we need to populate full name as a first name, middle name, and last name. So he's saying like we need to concatenate. Concatenate means uh, combining two different strings from two different places. So they're asking to combine the first name, middle name, and last name. So this is uh, one of the rule they are asking, and you can see for the country also they are asking only first two letters of the from the source we need to populate. For example, in the source we have the data like India or the Spain. So they are asking in the target it should only comes in the first two letters. Okay. So if you see in the database, I have one table called the employees where I'm storing the employees information. So here I'm trying to describe means trying to see the structure or the scheme of the uh, employees table where you can see employee ID. They will give even the column names how exactly it should be. So according to that only we need to design. So employee ID. He is saying not null means employee ID should not be null. What is meant by null? Null means empty or it's a void. Means there is nothing. Means null in the sense you don't you might not have even the space character also. Space character is also will considered as a one of the character in the text. Okay, it will not have anything. So so it's saying it should not be null means it should have any value. What is the value type? It should be number. And what is the length? 6. So let's see the sum of the data. If you see the employee ID, so you can see the numbers. So likewise, they will give this structure of the database. According to that structure only, we need to design the everything. So you can see varchar, the date, hide date is a date column, and number. Number also they say they given 8 comma 2 means it's a floating value. How is a floating value? 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers. After that, it should have only 2 digits. So they're asking to store the information like this. So this is a mapping document provided by the business where you need to understand all the columns. Actually, I'm showing you maybe around 11 columns uh, where the scenario I in the real time I worked, they will give all the maybe around 100 to 200 columns also. Out of that, actually, they will simply say, uh, let's say in the source I have maybe 200 columns. Out of that, I need only in the target maybe 10 or 20 columns mostly. They will mention that also. So out of these 200 columns, I need only 20 columns that should be available in target. For the 20 columns also, they will provide some logic. Your understanding, right? So that is the mapping document. This is not required. This is not required. Actually, this for the testing purpose. Okay, this is also not required. Okay, so that's the mapping document, and we'll try to understand the schema Okay, before that, I will tell you uh, this data warehouse concepts uh, and okay, data model. We'll discuss that now. So normally, uh, there are mainly you will be working with the two systems. One is the OLTP, one is the OLAP. What are those? I'll tell you. After that, we'll discuss about the differences between databases and data warehouse. Okay. Uh, so normally OLTP stands for online transactional processing. Means this OLTP, whatever you are using, it is a database which stores the daily transactions, or you can say the current data. Let's take you are using one bank. Out of that bank, you did some transactions today, around 10 transactions. So for those transactions, you might be receiving SMS. How you are getting that SMS? So first of all, your transactions will be captured in one database. On top of the transactions, whenever some changes happening on the account level, that will be notified to the customer. So that's how it is built. So for that, we need to capture some information, right? So what are the day-to-day transactions we are happening? That will be used. We'll be using this database. So this database. So whenever we are using some of the characteristics of OLTP, that comes under the database. Only databases will use this OLTP concept. Okay. So just a second. Yeah. So, for example, there are multiple changes happening. For example, customers comes and say, "I'm staying in this address, not this address. It has to be updated." And uh, customers making multiple transactions. Let's take a retail store. We have one retail store. There are some grocery store we have. Out of that, we are making lot. We are selling lot of the products. Maybe it's related to daily uh, products, whatever it may be. So for that, each individual product, we are making one transaction that will be captured in the database because it's even this database works as an inventory as well. Okay, where it will check the data. For example, they comes to you and they will ask, uh, let's take, they will ask for the bread. So in the store, they have the 10 quantity. How will get to know this information stored in the database? Okay, so he will check and uh, he will update it to you. Once the purchase is happened, let's take you brought it 2 bread packets. The inventory in the database, it will become 8. So everything will be handled internally. But before that, we need to have the minimum data. So this entire thing will happens in the normalization way. What is meaning by normalization? A normalization is nothing but uh, no duplicates. So for example, uh, we have one information in somewhere in the table 1 or in table 2. So we will not have the same information in another table. So it will not try to have the duplicate records. Even we'll call it as a redundancy. So this is in the normalized way, the OLTP. Okay. So OLAP is nothing but online analytical processing. The name itself self-explanatory. So it's nothing but this system will use it for the analytical purpose, means analysis purpose, you can say. So uh, this is wrong. So this works in the denormalization method. Means the whatever data you have, the same data you will be having in the other tables or other places as well, because this might be helpful to read the information and to improve the performance. Okay, so let's see the differences actually. You'll understand easily. So OLTP, generally we will use it for the operational systems. This we will use it for the data warehouse. Okay. Operational system means on day-to-day operations, whatever you are using. For example, I'll go back to the olden days, how we used to handle the data. Maybe in 1980s, we used to store the information. Uh, we used to store the data in ledgers or in the papers. If you remember, in the olden days, you even still uh, uh, now also we'll try to carry the we'll carry this passbooks, right? Bank passbooks and all. So those comes under papers. So after a few decades, we started using uh, computers. In that computers also, we simply used to have these files. What are those? Simply notepad, you can say. So nothing. So we started using this notepad. So it is difficult to handle the small information, that's fine, until unless. So it is very difficult to handle the large data. Okay. So that's why we moved to this Excel one. Okay. Microsoft Excel, or we'll call it as a spreadsheet and all. Then we came into this even like Excel, and we used to have this access. And then we came into this picture called the DBMS, and later we evolved it to RDBMS, and many more. Like even we started using this big data, Hadoop, and large. Even we are using cloud, so that's a different part. So that's how we evolved. So for this entire thing, mostly we'll be handling everything on the database level only. Okay, so the operations you are doing, you will be, for example, if you have these all characteristics, it comes under the OLTP. And the same, if we have this, it comes under the OLAP. So uh, it is designed to support the business transactions, whatever you take. For example, you have this clothing store, or you have this footwear store, whatever it may be. You have some products, you are doing some transactions, you are capturing somewhere. So that comes under this uh, OLTP only. It is an application oriented. Means I told you, right? Uh, Actually, this is the client. The Oracle SQL developer is a client software where I can interact with the server. So how what it will happen? Actually, I told you, right. So there are two. One is a client and one is the server. So this is the client where we will request some information. I'm asking some information to the server. So actually SQL term means uh, sequential query language where, or you can say structured query language where in a structured way means in a particular structure you will ask something, you will ask some question to a machine. Out for that question it will reply back. That is a SQL. So this is a client where I'll try to for our particular user purpose, to interaction purpose, like it's kind of a user interface will be easy. So even we can do the same in the run command also. Previously before this softwares we used to interact through the command prompt. So whatever you want to do, you need to give this in the command way. But later on we started using this client interface, graphical user interface, where you will have this console. You can see have all the features for the uh, to make your work easy. Okay, so there is one more in the back end that is called the server, which you can't see, which you can't you don't have the full permissions. Okay, so application to oriented means it is dependent on one particular application. Maybe you can say I'm referring to this Oracle SQL developer, or you can say any particular application you are using uh, to access this one. And this will store the current data, means the latest data from 6 months to 1 year. And if you see the OLAP, this will be used by the data warehouse. So warehouse, it's the structure is totally different compared to database. So both are the databases only, but we are calling this as a data warehouse because uh, the purpose we are serving or the purpose we are using, that's why we are calling it as a data warehouse, to identify them differently. Okay, and this is a subject oriented, means for example, out of the all the data we have, we will find out some uh, the information which is in a particular way. For example, if you take this database, you might have all the information related to everything. Out of that, you will pick up only one particular topic. On that only, you will do this analysis. So it is a subject oriented, and it can store the historical information. So whenever you are doing any analysis, you might need the more data for the accuracy or for the detailed information. For example, uh, let's say you have one customer, he made some transactions with you or purchases. With only one or two, you can't analyze how is the customer. So you need to know the customer behavior. So what he is purchasing, when he is purchasing, from where he is purchasing. So everything will be helpful. So we need many years of data. This is a detailed information we have. Detailed information means you'll have many columns which might be useful, might not be. So this is a summarized data where you'll have limited columns. Just now I told you, right? Somewhere. There. Yeah. In the mapping document, I told you, right? So out of 200 columns, you will only get only 20 columns. Why? So this is detailed information will be here. This is a only the what are the required information we need, that is maintained over here. And this is a volatile in the database. Volatile means that something which we can change, and non-volatile means some we can't change the what we say, that what are the information or data we stored. So for example, uh, we had one customer, uh, he made one $100 payment in the maybe yesterday. So will you go back and change the past? You can't change it, right? So it is already happened event. So that was they are referring for. So that's why we don't change the past information. Mostly we'll be providing with the uh, not all the users, but the limited users will be having. So for example, uh, this I agree this information is already happened and we can't change it, but there is one error or there is one mistake. This is not $100, it's $1,000. In that case, it should be updated, right? So only for uh, the leads in our team, technical lead or the manager will have the update access or correction access. We'll be having only the read access for the data. Okay. So that comes under the volatile and non-volatile. As I told you, we'll have the less history, we'll have the more history. Just a second. Uh, this is a denormalized data, and this is this is normalized and this is denormalized. And as I told you, this is a running the business and for the analysis purpose. ER model, I will tell you. Remember this ER model and dimensional model. These are some of the important two models you need to know. So we'll discuss it later. And this is the used by the uh, users who are the clericals, means who is in the front face of the database. And uh, this is data which can be accessed for the knowledge purpose. Okay. This is only for the maintenance purpose. The person who is maintaining, they will use for the clerical purpose, and this for the knowledge purpose. In terms of the storage capacity also, it will be different. This is in maybe 100 MBs to 2 GB or in somewhere around maybe 50 GB you can consider or 10 GB. I am saying approximately. Even this also recently database they are using more. So this is maybe more than this, greater than it will always greater than the OLTP. Okay. Indexes and joins you will understand once you understand some of the SQL concepts. Okay. So this is same again like what I explained, right? So database and data warehouse, it's the same. Again, it comes under the same kind of meaning. So I forgot to tell you the main concept, the data warehouse. Data warehouse is nothing but it's a combination of the data from multiple sources into one place where, as I told you, it's for the analysis or the transformation or reporting, or maybe this can uh, uh, acts as a repository for the entire database. That's the one thing. And uh, it has some characteristics. Okay, we've already discussed. As we discussed, like it's a subject oriented, and it's a integrated. Integrated means like you are integrating. Means you are getting the data from multiple of different places to a single place. That comes under the integrated. And the time variant. Time variant is nothing but according to the time, the information might change. For example, okay, you will understand this concept when I say the uh, slowly changing dimension. Okay, there is one concept called the slowly changing dimension. You will understand this time variant. Okay, so slowly, for example, we are uh, holding some information in a time being repeated. The information might change slowly. Okay, The non-tile, we can't change it. So you're following, right, you guys? Or like uh, if you feel like you have any doubts, you can stop me at any time. Uh, we'll have a discussion on that doubt. Okay. You can tell me like if I'm going slow or fast, or if you're not understanding anywhere, like we'll discuss it again. Uh, okay. Uh, Data warehouse. Maybe we discussed STLC. It comes again under the agile, so I need to check with them. So data model. We'll discuss about the data model and fact table and dimension table. Okay. So actually, I'll say you like so for you guys, they only asked you to uh, train you on only the high part and ControlM. But even I'm trying to cover this ETL part because without understanding the basics or the roots of the data or some concepts, you're directly jumping into the directly big data part. You might miss some of the understanding. You might not understand. Uh, so somewhere like they are using these terminologies and all, you might miss that connection. So that's why I'm trying to cover this information. So I hope this will be uh, helpful in your projects or in further. Okay. So like again, you might you can go back and you can check the more detailed information. So as this is a crash course, I'm just giving you the basic understanding or the a little information which only useful for to you, like just for the understanding. That's it. If if we if I give you the more information, you might confuse or you might forget all the basic concepts. Okay. You guys are following, right?
Yes, Mani. Yeah.
Okay, again. So uh, we'll discuss about the data model, fact table, and dimension table. Uh, so normally, I told you, right? So we'll be working with this team. So there is one hierarchy we'll follow. This is not a hierarchy, I can say. This is a technical team we work with. So the business analyst, he will give the business to us, means he will get the requirements from the business team. And out of that business, what exactly we need to design. So either business analyst or PO, you can call it as a product owner. So both are same, a little different they have. So they will get this business data, and he or she will interact with this person called the data architect. Data architect is a person who will create a entire flow or the architecture of the data, how it should be stored. On top of it only, we will work as a developer or as a uh, designer. You will need to design everything. For example, uh, uh, if I say you in simpler terms, uh, you know this uh, civil architect, right? So what exactly the civil architect will do? He will just give the blueprint, or you can say the layout or plan of the building. So he will just design which room or which uh, one it should be in which place. He'll just give you the measurements, and he will just give you the size, or he will just give you which or bedroom or hall where exactly it should be. According to that, the worker who is working, or you can say the contractor or the next person, they will pick up this layout or plan. According to that, they will start building the the building. Okay, so where this civil, just like that, this data architect create one data model. So it's in the three different levels. One is a conceptual data model, logical data model, and physical data model. So how I tell you, so if I take the conceptual data model, this comes in the higher level. For example, let's take we want to start the project. We already have the initial phase of discussion. In that discussion, we started to know that we are using some of the components, like let's take components, or you can say the modules, product. So not they will give like this. They will just give you the information. So there is story like this. So they will say we are having one product, we will be selling to our customers. By that, we'll be generating some sales. For that, we are uh, maybe let's take for example, we will try to sell these products for upcoming 2 years. In particular, maybe 3 to 4 stores. So he will give you some story like this. According to that story or so that information, so this data architect has to come with this conceptual data model. So what is exactly the conceptual data model? So conceptual data model is nothing but, if you see, it will have only the entities or relation among them. Entity is nothing but the something which is not clearly defined initially. So if you see, we are saying the product, but we don't know what exactly the product we are referring to. So we just know it's a product. We don't know how many products we have, or we don't know who is the customers. We don't know nothing. So in that scenario, we'll call them as a entities. So if you're working in your real-time projects, right? So they might using these terminologies like entities, the relation, or records, rows, or fields they will use. So attributes. Attributes means the columns. Entity means you can say the table. So the table which we not define clearly, or the attributes. Attributes means the columns we not define clearly. And primary key. Primary key is nothing but uh, the column or main one in each individual entity. So let's take in the product, we'll get to know in the next level. So this is a conceptual data model. So what exactly happen means, this data architect will do this conceptual data model, and he will take the approval from the business. So I designed this one. If you see, uh, so these are the entities we are using and all. If you approve, I will go to the next level. Okay. So this is approved. So what exactly he will do? He will go to the next level, which is a logical data model. In terms of logically, if you whatever you're working, so in this layer, he will try to implement attributes for the each entity, even the primary key as well. If you see here, if I show you the image, hmm, for the product, before we don't have anything, but yeah. So before you don't have anything, but here you have the product type, you have the product description. Means in each entity, even you have this product number as well. So each entity, we are having these columns, and even the primary key, which is the important column. So primary key is nothing but is main column in a table, or you can say the entity, which will not have null values and no duplicates. For example, you might be having uh, uh, for example, you might having one product, or so like just a second. So uh, so for example, let's take shoes. So for the shoes also, uh, you might have the same shoe uh, number or shoe color, but in other terms, uh, shoe uh, company will be different, and shoe model will be different. So you can consider that shoe model as a product number. So according to that model, if you search with some model name, you can see shoe color, shoe number, from where it got, from where it's going. So the detailed description. So likewise, like uh, you'll have the column names for each and every component and the relation between them. If you see the product number, whatever you have, that is saved here itself. So if you have the same column, then only we can create a relation between two different entities. If you observe here, date ID, this date ID is over here. Okay. So whenever, like if you build something in the tables level, you need one common column between the different two tables for the building the relation. So he will, what exactly he will do? He'll simply add the column names, the PK column, and again you take the approval. Then he moves to next level, which is the primary key. Sorry, physical model. So physical model is nothing but a fully designed or fully implemented. Means you have the entire design ready with you fully. For example, you can say you have all the column names, all the table, and even you have this foreign key. Foreign key is nothing but oh, sorry. Foreign key is nothing but it's a common column between two tables. It will help us to join the two tables and get the data. Okay. So foreign key will be helpful to join the two tables and get the data. Foreign key will be, for example, the primary key, which is the main column in the product table. It will not be main column in the another table. So that's acts as a foreign key. Okay. Even you can see, even we have this data length or data type also. So once you have this everything, this comes under the physical model. Means you will be having the table name, you will be having the column names, you will be having the whether it is a primary key or foreign key, and you will having the data type and data length, everything, and the proper relation between them. This comes under the physical model. Once this is ready, he will give you this information to the developer, not everything. So first example, uh, you have we have three persons over here. Let's take Irfan, Nagendra, and Pawan. So what they will do, one product will be given to one person, Irfan. This salesperson sales will be given to Pawan, and other one will Nagendra. So he will ask you to design this one. So how you will design? For uh, according to your technical knowledge, whatever you have, the programming language. So maybe in some projects they may be using Java. In some other projects they're using .NET. So mostly in data warehouse or this data engineer role, mostly you will be using the combination of Python with the SQL, okay, or simply standalone SQL. So, or you might even you might use the cloud, but it's a different one. But the minimum one is the SQL. Recently, we for this cloud also they started using this PySpark. In the PySpark also, if you see half of the code will be written using SQL only. Means whenever you are trying to interact with any database, the SQL one is the mandate. Okay. So SQL, after that we got NoSQL, TSQL, we have many, but SQL is a standalone query language which will help us to interact with the database, so that you can fetch the data, or you can write the data, you can manipulate the data, whatever you want to do with the data, you can do. Okay. So this developer will do the designing part, and then again it will be given to a tester, and this will goes from the different environments. How it will go? Initially, the code, whatever the code we are working, it will be in the development environment. Once the code is ready, it will be moved to test environment, and then it will be moved to uh, we have levels of production environment. You can simply uh, have this production. Before that, this testing, some might use this pre-prod, UAT, we have many, but in simpler terms, you can have these three mainly. So that's for this moving this code, we might use this GitHub uh, or Jenkins. You heard about the Jenkins and all. It will be helpful to moving the code from one environment to another environment. Okay. So for maintaining a versioning of the code and all, or merging the code, whatever you want to do, you can do this in GitHub. For example, you designed one SQL file with the version 3.0. What happened? They asking us to change, do some changes. You want to move this code to production, but this v1 is not working. You can revert back this v1 to v0, and you can run the production code. So the time being, until unless this v1 is fixed, you can revert back and you can place this code over here. Once this is fixed, you can place this code here. So that's how this GitHub will be useful. Uh, so this is the physical data model. So these are some of the differences, and what we're discussing. Yeah. So database objects are nothing but the some of the actually in the database we'll be having some objects. For uh, each object, it has own their functionality, or their own use. For example, table, if you take, what exactly table does means, table will store the information in rows and columns. That's it. Where it is. If you see the table, if I see the data, you can see the data, right? So it's stored in the rows and columns. This is called a table. And the view is nothing but it's a kind of a mirror, or it's just a uh, it is also kind of table, but it will not utilize the storage. So it will just show the data whatever the table we have. For example, we have data in table, so that will again it will be reflected in the view. That's it. Means if you do some changes in table level, that changes will happen in table also. If you, for example, I'll give you some, for example, I'm making some changes. So the same information will be reflected in the Viv as well. That's it. Why this is useful means, let's take you are the person, you need to work on entire data. Because of that, you have the all the permissions. But for the few teams of few users, you don't need to give all the details. Uh, for example, maybe other users, they just need to see the data. That's it. They don't want to. We don't want to edit any person this information. So they will only want to give the read access. So we can't give the original details or table information. That's why we will create one view and we will give it to them. So they can only see the data. They can't modify it. So that's how this view will be helpful. And the function is nothing but some group of statements will execute. Like for example, you are running daily, inserting 10 records, updating 10 records, and deleting 10 records. So whenever you are doing this, why can't we create one function and place these three inserts over there? So whenever I'm calling this function, right? So if I run this function, it will automatically, it will perform some set of statements which we mentioned in the function. Okay. Stored positions are also same, but in terms of the format and it will be different. That's it. Till here, do you have any doubts or questions? Okay. This is not required. Okay, snowflake. Okay, before that we will so we'll cover this fact table and dimension table. Uh, yeah. So uh, if you are working in the data warehouse, right? In a data warehouse, uh, we might be using only two types of data tables. That's it. One is fact table. Another one is the dimension table. That's it. How it will be used? We will be using if you see here, so this is how we store the data in the data warehouse. Wait. Mm. So if you see here, uh, so whenever you are storing the data in the data warehouse, data warehouse will only use the dimensional model. It will only use the dimensional data model where you will be having one table in the center, which is a main table, and this main table will be surrounded by the supporting tables. That's it. So uh, you can't have multiple tables which are continuously related to each and one other, keep on going, not like that. So there will be one table in the center which will hold only the numbers, and this will be used by the business analysis, this table only. And the supporting information which we want, that will be stored in these surrounded tables. So we will see the what are the types of table. This is one type. These surrounded tables are second type, type 2. So type 1, which is, we call it as a fact table. What is exactly the fact table is, the fact table is a table which contains only the numeric values. Means you will have only the numbers which is used for the business analysis purpose. So if I show you if you see the fact table, it will have example the fact table. This is how it looks like. Let's take the sales table. This is the main table. It has the data, and it is storing only the number values. That's it, which can be used for the business analysis. Okay. And this fact table is a main table, primary table in the dimension data model, which can contains only the measurement or metrics or the facts. Facts, you know the word, right? Fact means which is the real, or which we are what we say. Just a second, I'll tell you. Fact, it's what exactly it's referring for. So which is already proven, or which it said as it, which is a true. So in this fact table also, uh, this fact table actually will be center of the schema. Actually, we have two schemas. One is the star schema, one is snowflake schema. I'll tell you. So in this star schema, sorry, uh, it is a center of the schema. So these are the two types. One is the conformed fact, and another one is a factless fact. Conformed fact means which is already conformed by all the dimensions, across all the dimensions. Means what are the data you are storing this information. It is already confirmed that uh, this is already proven, and it can be used for the what we say um, for the analysis purpose. The factless fact is nothing but which is not uh, which cannot be used across all the dimensions. Means uh, that is the information which is not proven fully. Okay. Even these types of facts also, for example, let's take, we have three columns. uh, Whatever the column you have, it should be defined, either it should be additive fact, semi-additive, or non-additive. What are the types of facts we have? uh, we can apply all the aggregative functions. It comes under the what we say, it's an additive fact. Let's take, there is one column called the salary column. So I have this salary column. In this salary column, you can apply this aggregative functions, right? What are the aggregative functions? Minimum, maximum, average, sum, and count. If you see, uh, if I want to perform something on this salary part, this is a salary column we have. I can get the minimum value out of it, maximum value out of this, or I can get the average, I can do the count, I can do the sum. So on single column, I can get the minimum value, maximum value, average, count, and sum. So these are all the valid values I am getting. Means it has some proper meaning. So out of salary, there is a minimum salary for a particular. Uh, just a second. Yeah. So out of this, you have this minimum salary, maximum salary. So that comes under the additive fact. Where is a semi-additive? Let's take, there is one column called dependent column. I can't apply some of the all the functions. Only maybe some of the additive functions, aggregative functions we can apply. Means either it may be a minimum or maximum or count. We can't get the sum, right? For example, even though you get the sum, there is no proper meaning. Even you can apply the average also, but there is no proper meaning. So if I do in the department number, we have 90, 90, 50, 60, everything. But if you do average, there might get in the floating value, maybe 100.21, 100.2. So there is any value with 100.1 or 2, even though we'll get it, there is no proper meaning. So that's why we cannot apply some of the functions. So that is the semi-additive. Non-additive means we can't apply any aggregative functions. For example, let's take comments column. So we can't apply any any function. That's a non-additive. Okay. So this is a fact table, whereas the dimension, there is one more table type, I told you, right? That is a dimension table. So dimension table is nothing but, where it is, table where we will store the descriptive information. Means you will store the detailed information about any particular one from the fact table. Let's take this example. So in this fact table, I have this information. If I want to know the detailed descriptive information, right, I need to I need to go to this dimension table, just like I told you, right? So, yeah. So I need to go to this so that I can understand about that project. Sorry, product. For example, I have this product ID. I don't know what is the one is, what is two I'm referring to. But for this one product, I got around 400 profit, maybe some 300 revenue I got. Maybe I did some, maybe in terms of quantity also, maybe I did maybe this many. So I want to know what exactly this product is. I can go to this product table. I can see over here. Okay, product one is uh, which is a brand Nike, red color, and this is a manufacture date, or maybe selling date, or you can see the detailed information in the dimension table. Okay. So whatever the PK column we have here, it will be a foreign key in the fact table. Okay. So that's the one thing. So this dimension model is nothing but it's a it will have the descriptive information of the fact table. That's it. So in that also we have types. What are those? Type 1, type 2, and type 3. If you see the dimension model type 1, the old value will be replaced with new value and no history will be maintained. I told you, right? Uh, in the data warehousing concepts, it's a time variant, means according to time, the information will continuously changes. So mostly uh, companies will use this type 2. You don't need to remember type 1 or type 3, but you need to understand, okay, like what exactly happening, so that you can at least differentiate between these. So type 1 is nothing but old value will be replaced with new value. Type 2 is nothing but new value will be created, new row, or new record, we can say. New record or row will be created with new value, and all the detailed information will be maintained over here. Okay. And type 3 is nothing but only the one time history will be maintained. Let's see the different, what we say, examples. Okay, not this one. Yeah. Uh, you understood till here, right? So slowly changing dimensions is one of the important concept in a data warehouse. So yeah, you understand these dimensions, right? Dimension is nothing but you'll have, for example, I'll tell you clearly for your sake. Uh, let's say we have one fact table which will store the employee ID only. Let's say for time being 1, 2, 3, 4, 5, 6. So this is storing only the employee ID. For example, fact table. If I go to the dimension table, what I told you, it will store the descriptive information. For this employee ID, it will store all the descriptive information about, like, who is the employee ID, what is his salary, in which department he is working, or location where he is working, all the information, or let's take any hike he got, or maybe in which project he is working. Every detailed information will be stored here. If you want to refer any information of this employee ID, you can come to this dimension table. You can see maybe Mandeep, salary, department 10, location Hyderabad, height maybe 100 plus, project maybe SDC. So like this. So you can see all the detailed information about the employee. So that's how this dimension table will be useful. And for this dimension table also, we follow one concept called the SCD. SCD is nothing but slowly changing dimension. Means according to the time, the data will change slowly. If I say you, in this employee table, let's take one example. You have this data. So for this data, if I go with the type 1, means no history will be maintained. Uh, uh, if you work in projects, right, they will only use any one of the type, not all the types. Okay, so they will use any one of the type. Mostly they will go with this full history, because you can have entire details about the customer or whatever they are working on. So if I take say we have this information, let's take any particular one they are using, type 1, no history maintained. So initially Raj is working on Hyderabad location. So he uh, he was relocated from Hyderabad to maybe Delhi. So you don't know the previous location where the Raj is worked, because you'll have only the latest information. That's it. If we use this type 1 again, if he relocated from Delhi to Pune, you will only see the Pune. That's it. You don't know whether how many locations he worked and what he did. That is called the type 1. No history will be maintained. Whereas in the type 2, the full history will be maintained. Means whatever the changes happens for any particular customer or the data, it will be captured clearly. How it will be captured, we'll see. So we have this Raj. Initially, he worked he worked in Hyderabad location. Manager is king. He worked in the software engineer designation. And later, what happened? The Raj is promoted to senior software engineer. So for that, it will not hmm, it will not update the data. It will create one more record in the database. with the new information. Means he is promoted to senior software engineer. So uh, so the new record will be inserted, and again he is relocated to Pune. For that also there is one record is created. So can you tell me, out of these records, which one is the latest one, or which one is the old one, or which one is uh, the changes happened recently? We can't, right? So without like I can see here, but I don't know how it is happened, and so for that only, for full history maintained, we'll be using some special columns called the active flag or valid flag or insert or updated date. By this, they will get to know how these records are flowing into the data warehouse. For example, initially, Raj, uh, he is promoted from senior engineer to software engineer to senior software engineer. They will mention this is as a active 0 and this is 1, or example say this is false or this is true, or yeah, for now you can remember this one. So what exactly happened? Again, Raj is moved from Hyderabad to Pune, I told you, right? So what exactly will happen? This old record will be updated with 0 and false. Means this record is available in the data warehouse. But we are saying this data is, we are not using no more. This data is a past history. And this is the latest information we should be using for analysis purpose. Okay. So, or else you can have this data is inserted in the June month, and we updated this information in the same month on the 20th. Likewise, again we got information here, here. So what are the changes will happen? You will capture through this flag columns, we'll say. By these flag columns only, you will identify whether this record is latest or old one. Okay. So that's the one thing. This mostly companies around 90 to 95%, they will use this full history type 2 one. And there is one more type called the type 3, which is a one-time history. Means, for example, let's take this is person, there is person Raj again. He's moved from Hyderabad to Pune, or else he started a job as a fresher. He started working on the Pune, and he was relocated from Pune to Hyderabad. Okay, this current location will comes to the previous, and the latest one comes into Hyderabad. Again, what happened? He moved from Hyderabad to maybe somewhere called Noida. So what exactly happened? We don't know initially where he worked, but on the recent one and the previous one, he is working on these place. He worked on these place. He's working on this place. So this is called the one-time history. So where we can see the latest information and one step back. That's it. So do you have any doubts or questions on this concept? If you okay, so if you don't understand or if you stuck somewhere, you can reach me anytime. Like I'll try to explain again. Okay. So where are we? uh, STLC. Okay. OLAP will code data model cover. Okay. We will see lastly what is the star schemas, and we'll close the session. And these are all are not required actually. Actually, this document related I teach it for the ETL testing students as well. So only some of the concepts will be useful for you. I'll share this document as well for the reference. Okay. Actually, I don't have access for the Google Drive from InfoCloud. Most probably, I will get the access today. So I'll upload the recordings and I'll share with you. So coming to the schemas, I told you, right? Uh, uh, we work in this dimension model. This dimension model also, we have two types. One is the snowflake schema. One is the snowflake schema. One is the star schema. Before that, what is meant by schema? Schema is nothing but it's a simply a collection of tables, you can say, or it's a structure of the database. Simply, it will show how the data is stored in the database. So, by seeing this schema, we can simply understand how the data is stored in the database. Okay. So, in this schema also we have two types. One is a star schema, snowflake schema. So, for example, let's take what is a star schema, what is a snowflake schema. Star schema is nothing but the fact table. I told you, right? The center one will always call it as a fact table, which will store all the detailed, not the detail, all the main information will be stored here. And this fact table is surrounded by the dimension table. This is called as a star schema. I'm not sure, but they will call this is as a star schema. So if you see from very far, it's like a star where it's a star kind of a shape. So where all are interlinked. If you comes to the, let's take star, in the star, every dots, every lines are interlinked. So that's why they are saying this as a star schema. And there is one more called the snowflake schema. Snowflake schema is nothing but we have this fact table. For this fact table also, we can have these dimension tables. Again, for these dimension tables also, we'll have a connected dimension tables. That comes under the snowflake schema. This snowflake schema will be helpful in the complex projects. For example, you are handling very large data set where you can't understand information by using this star schema. That's why, for example, if you take the time dimension, if you want, you can store the time dimension. Just a second. You can store this time dimension in more categorized or more, you can split it into more, right? Into months, into dates, into years and all. So like that's how like we store the data, and we can fetch the data and we can work on it. So this snow star schema is nothing but a fact table is surrounded by dimension tables, and snowflake schema is nothing but fact table is surrounded by dimension. These dimensions also surrounded by extended dimensions, other dimension tables. Okay. Uh, actually we have with this name Snowflake, we have this schema, as well as there is recently there is one more database with the name called Snowflake also. So Snowflake scheme database we have, Snowflake scheme also we have. Okay. So simple, like mostly like in the practical way we don't use it anywhere, but yeah, in a higher level, whatever the projects you are working on, they are dependent on whatever we discussed only. Okay. What are uh, even one more thing, if you go to any interviews also, for the data, and even if you take in the data engineer or any position, they might ask any one of these concepts. Okay. So even that way it will be helpful for you. Hello. See the are you guys there?
Yes.
Can't see the panel. Okay. Yeah, I got it. So these are the some of the basic or concepts we need to know. So apart from that, even you need to know about SDLC and STLC also. I'll check with them, and if they and I try to cover it. Meanwhile, like you can go back and you can do this homework. Just at least spend at least 10 to 15 minutes. That will be fine. Uh, Try to search about the data governance in that Colibra, what it is exactly, and OLTP and OLAP. So you'll get more understanding. Okay. So we'll connect tomorrow and we'll start with the Hive.
Yeah. Hi, Mani. Can you share the recordings as well and the PDF? Once we go through the recording, maybe we might be able to understand more. I mean, for searching in internet, if we miss something or if we're not sure about what exactly it is,
Yeah.
it would be helpful for us.
Sure. Like just most probably today I'll share the this recordings. Okay.